Hello my dear students, very good morning to all of you. In this video lecture we will discuss very important concept of class 10th and chapter is periodic table and periodicity in properties. In my previous video lecture we talked about the concept of periodic trend and it was first concept and topic was valency and valence electron. So we discussed on that video lecture how we can calculate valency or valence electron with the help of electronic configuration. And today for atomic radius or atomic size or atomic radii all together sounds equal, correct? So for this topic we will take help of electronic configuration as well, correct? So first of all, as we used to discuss, the first point is key point, and for definition I took one example for understand the concept of atomic radius, correct? It is Bohr-Bury model and it is electronic representation, or we can say electron dot representation of an atom, correct? So I took lithium and atomic number of lithium is 3, so that if I will write its electronic configuration, I will use 2 shell because first shell, that is K shell, its maximum occupancy is how much? It is 2. So remaining 1 electron will jump or will fill by L shell, correct? So total 3 electrons, therefore 3 protons, because atom is nothing but it is an neutral species, correct? So if I will represent lithium, so in K shell, that is first shell, there will be 2 electron, and next shell is L shell, there is 1 electron, correct? This 1 electron, this L shell electron, we can circle it. This L shell electron is also known as outermost valence shell electron. So how I will define that atomic radius? So in an atom, in that particular atom, the distance between outermost electron, that is far electron very far from nucleus, outermost valence shell electron and the nucleus, the distance between center of the atom, that is nucleus, to that outermost electron is known as atomic radius. The distance from here to here, or we can write here to here, it is what? It is atomic radius, correct? Just like radius of circle, nothing else. So for atomic radius we have to focus on outermost valence shell electron, number 1, number 2 nucleus, and number 3 their distance, correct? So to understanding well the concept atomic radius, I will focus on 2 term, number 1 number of cell and number 2 nuclear charge. So in periodic table, because we are studying periodic trends, and for trends we used to discuss periodic table like down the group, means in a periodic table we study trends top to bottom, then after top to bottom the term is in a group, or we can say it's a periodicity in property in the group, and then further we go to left to right, or we can say along the period, it is known as periodicity property in along or we can say along the group, correct? So atomic radius is directly proportional to number of cell when we study in a group, and atomic radius is inversely proportional to nuclear charge when we study it in a period. So nuclear charge in a period and in a group, it is number of shell. So one by one we will emphasize this topic, the concept of atomic radius versus number of shell, and second one is atomic radius versus nuclear charge. So see here, it is number of cell versus atomic radius, correct? So for the understanding or for explaining the concept of number of shell and atomic radius, I would like to focus on one group that is also known as alkali metal group, and first group as well of S block element, in which first member of hydrogen, I ignored it, then lithium, sodium, potassium, rubidium, cesium. These are the member of first group element. So because number of cell I used to study in the group, so that I took one example from that group, correct? And it is known as down the group. What is this? It is known as down the group. So lithium, its atomic number is 3. For sodium, its atomic number 11. For potassium, its atomic number 19. Correct? And further, it is rubidium and cesium. So, for lithium, its atomic number 3 means it has how much electron? 3 electron, and further it is 3 proton. And 3 electron and 3 proton, or basically for 3 electron, I will use KLMN electronic configuration system. So in K shell maximum 2 and L shell maximum 1 electron can be occupied, correct? For sodium, its atomic number 11, so its electron will be 3 electron and proton will be also 3. Sorry, it's not 3 exactly, it is 11 electron and it is nothing but it is also 11 proton, correct? So it's the next concept. So see here, as compared to lithium and sodium, there are total shell K shell and L shell, but in the case of sodium, here total 3 shells K, L, M, because I have 11 electrons, and for 11 electrons I can maximum put 2 electron on K shell, then next 8 electron, maximum occupancy of L shell is 8 electrons, so further next electron will occupy by M shell. So comparatively here one cell is extra, correct? Here total 2 shells, here 3 shells. See here, for potassium, here total 19 electron, so K, L, M, N. Why I used M, N shell last shell? Because total 18 electron will be occupied by K, L, M, and the next 19 electron or last electron will be filled in N shell, correct? So if I will compare all these, there are 2 shells, 3 cells, 4 cells. Means as number of shell increases, see here its size is like this, its size is like little bigger, but for potassium it is more bigger, correct? Because number of shell is added. So as we move down the group, because of adding of one extra shell to that particular element, size increases, hence atomic radius also increases. So down the group, because number of cell increases, because this sign indicates increases, because number of cell increases, hence as a result atomic radius also increases. I think this concept is clear. Because number of cell increases, therefore atomic radius also increases. Lithium is little smaller than sodium and sodium is smaller than potassium, correct? So it is clear, number of cell versus atomic radius. Now next concept is nuclear charge versus atomic radius, and this concept we discussed in along the period, correct? So I took the element of second period, that is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and I study its left to right. That's why I indicate this sign left to, I'm moving left to right, correct? So I took first element of second period, and the second last, it is fluorine, correct? So for lithium, there are 3 atomic number 3, so 3 electron, 3 proton. Similarly for fluorine, there it is atomic number 9, so it has 9 electron and 9 proton. So students, I would like to focus on this concept, nuclear charge. Nuclear charge, if I will go for further postmortem, nuclear charge means charge of nucleus, correct? And what is nucleus? Nucleus is the combination of 2 particles. If I am not wrong, nucleus is the combination of 2 particles, number 1 proton, number 2 neutron, and around nucleus electron revolve, correct? So it is nothing but the particular atom, correct? Atom, there are 3 particles, electron, proton and neutron. So because proton is a positively charged species and neutron is neutral, so whatever the charge of nucleus is due to proton only, correct? So in lithium there are 3 proton, and in in fluorine there are 9 proton. So as number of proton increases, As number of proton increases, nuclear charge increases. And when nuclear charge increases means nuclear is more powerful. Here the nucleus of fluorine is strong, much strong than the nucleus of lithium. So when this site is maximum positivity and comparatively this nucleus has minimum positivity. So what further result? This nucleus will attract the electron cloud that are revolving it around it. It will attract the all electron cloud towards itself more effectively than this nucleus. Correct? Why it is so? Because it has less number of proton. Here number of proton are more. So because of strongness of nucleus as compared to here nucleus is more strong than the nucleus of lithium. Because of more proton, here less proton, it will attract outermost electron cloud towards itself more effectively, and further result will be the electron cloud will be attracted towards nucleus more than this nucleus, and result it will be shrink. The size will little shrink because he will attract, just like we pull kite when we used to fly our kite in the our environment, and when the time is over we just pull it towards ourselves. Correct? Same like this. So nuclear charge is nothing but the charge of nucleus, or it is the electron cloud attracting tendency. As I discussed here in this diagram, it is what? It is electron cloud attracting tendency of nucleus towards itself. And number 2, nuclear charge is directly proportional to number of proton. So as we move along the period, number of proton increases, and number of proton increases, therefore nuclear charge increases. If nuclear charge increases, atomic radius will decreases because there is inversely proportional relation. Correct? So now we are on conclusion. Along the period or down the group. So first of all, down the group or top to bottom, atomic radius directly proportional to number of cell means as number of cell increases, atomic radius also increases. So down the group, atomic radius increases. Result is what? Down the group, atomic radius increases. Means if I will arrange in increasing order of these particular element, the order will be lithium A will be lesser than sodium, sodium will be lesser than potassium, then rubidium, and then cesium. I think it is clear. Now for atomic radius along the period, left to right, atomic radius is inversely to the nuclear charge, and here I written in detail as number of proton increases, nuclear charge also increases. See this, and we already discussed it with this comparison. Correct? So electron cloud attracting tendency of nucleus also increases because nucleus is on that time nucleus will be more powerful. So what will be result? It is shrinking of size, or size shrinks. So along the period atomic radius decreases. Correct? Why decreases? Because as number of proton increases, the electron cloud attracting tendency of nucleus as compared to that element which has less number of proton here increases. Electron cloud attracting tendency of the nucleus will be increases in this case than this case. So size will be shrink. So left to right or along the period size what? Size decreases. So if I will arrange these element which belongs to second period, the maximum size will be for lithium, then beryllium, then boron, carbon, nitrogen, oxygen, fluorine. Fluorine will be smallest, and lithium will be biggest among these. Correct? So the concept is, I think, clear to all. And again, if you have any problem, you can repeat this video. And for any problem, you can comment me, you can text me, so that we can discuss in detail or we can clear our doubt. Correct? So for next video lecture, It will be about metallic radius or metallic property as well. Whatever the written in the 10th class, we will discuss accordingly, and we will focus on electronegativity also, so that we will be able to understand what is the periodic trends actually and how they varied down the group and left to right, correct? So till then we will meet again. So now I would like to stop my lecture, and so thank you, thanks all.